Our immune system is a complex network of cells and organs that work together to protect us from infections. Think of it as our body's security system, always on alert for harmful invaders like viruses and bacteria. Within this intricate system, CD4 cells, also known as helper T cells, play a crucial role. These cells are like the commanders of our immune army, directing other immune cells to fight off infections. CD4 cells are like the body's intelligence officers. They identify threats and alert the immune system to their presence. When a foreign invader, such as a virus or bacteria, enters our body, CD4 cells recognize it as a threat. They then release chemical signals called cytokines that activate other immune cells like killer T cells to destroy the invader. Without CD4 cells, our immune system would be like an army without leaders. It would struggle to mount an effective defense against infections. This is why HIV, the virus that causes AIDS, specifically targets and destroys CD4 cells. The destruction of CD4 cells by HIV weakens the immune system, leaving the body vulnerable to a wide range of infections. This is what makes HIV so dangerous. It disarms the very system designed to protect us. HIV is a type of virus called a retrovirus. This means it has RNA as its genetic material instead of DNA. To infect a cell, HIV must first attach itself to the surface of the cell and inject its RNA into it. HIV does this by targeting a specific receptor on the surface of CD4 cells called the CD4 receptor. Think of the CD4 receptor as a doorway into the cell. HIV has a key that fits perfectly into this doorway, allowing it to unlock the cell and gain entry. Once inside, HIV uses its RNA to take over the cell's machinery, turning it into a factory for producing more HIV. The newly produced HIV then buds off from the infected CD4 cell, ready to infect other CD4 cells. This process of infection and replication continues, leading to a gradual but steady decline in the number of CD4 cells in the body. As HIV replicates, it causes damage to the infected CD4 cells. This damage eventually leads to the death of the CD4 cell. Over time, the continuous infection and destruction of CD4 cells significantly weaken the immune system. As HIV infection progresses and the number of CD4 cells declines, the immune system becomes increasingly compromised. This weakened state, known as immunodeficiency, leaves the body susceptible to a wide range of opportunistic infections. Opportunistic infections are infections that rarely cause illness in people with healthy immune systems. However, in individuals with weakened immune systems, these infections can be very serious and even life-threatening. Examples of opportunistic infections include pneumocystis pneumonia, a severe lung infection, and Kaposi's sarcoma, a type of cancer that causes lesions to grow on the skin and internal organs. The severity of opportunistic infections is directly related to the level of CD4 cell depletion. As the CD4 cell count drops, the risk and severity of these infections increase. This is why monitoring CD4 cell count is crucial in managing HIV infection. CD4 cell count is a measure of the number of CD4 cells in a sample of blood. It is expressed as the number of cells per cubic millimeter of blood. A healthy individual typically has a CD4 count between 500 and 1,500 cells per cubic millimeter. Monitoring CD4 cell count is essential for several reasons. First, it helps determine the stage of HIV infection. Individuals with CD4 counts below 200 cells per cubic millimeter are considered to have AIDS, the most advanced stage of HIV infection. Second, CD4 count helps guide treatment decisions. Healthcare providers use CD4 counts to determine when to start antiretroviral therapy, a type of medication that suppresses HIV replication and helps the immune system recover. Regular monitoring of CD4 counts allows healthcare providers to assess the effectiveness of antiretroviral therapy and make adjustments as needed.